Welcome students. We are back with another lesson. In this lesson we'll discuss Law of Malice and plane of polarization and plane of vibration. In our previous class we had discussed about polarization. In polarization, a unpolarized wave, the wave which has vibrations in all directions, is being converted into a polarized wave. That means vibrations in only one direction by using a polarizer. And the phenomenon is known as your polarization. Fine. Then we have discussed about law of malice. The law of malice states that the intensity of the light which is coming out of your analyzer depends upon the angle of the axis of the polarizer and the axis of the analyzer. That means this angle, theta. If this red represents the axis of the polarization, okay. What is the axis of the polarization? Okay, by axis I mean your x-axis, your y-axis and your z-axis. So this represents the polarizer axis, which is in your y direction. So all of the waves coming out of this polarization will be vibrating along y-axis. The blue axis represents your axis of the analyzer, in which direction your analyzer is oriented. It is between x and y direction. So in this case, this red one represents the axis of polarization and the blue one represents your axis of analyzer. So if I draw only xy axis, then look here, the red one is your plane of polarizer and this is the plane of analyzer, and the angle between them is known as theta. So in first case, when the plane of polarizer and plane of analyzer, this one, they are pointing in the same direction. If they are pointing in the same direction, then this is the plane of analyzer and this is the plane of polarizer. In this case, my theta will be 0 degree. Fine, that means the plane of polarizer and the plane of analyzer, they coincide. In that case, maximum light passes through. Next, you rotate the analyzer somewhere in this angle, thus giving a picture of theta angle. So when this is the plane of polarizer and this is the plane of analyzer, that means angle is coming into picture, therefore less light is coming out of this analyzer. Now if you rotate the analyzer by an angle of 90 degree, like in this case, this is the axis of polarizer, this is the axis of analyzer, they are at an angle of 90 degree. In that case, no light is coming out. So the intensity of the light coming out of the analyzer is given by the law of Malus. So according to the law of Malus, the intensity of the light coming out of the analyzer, I, equals to I naught times cos square theta, where I naught is the initial intensity, the intensity of the unpolarized light, and how much light is coming out is given by I naught cos square theta. Next, let's solve a numerical on the law of Malus. So two polaroids are used to study polarization. By two polaroids means your analyzer and your polarizer. One of them, the polarizer, is kept fixed and the other, the analyzer, is initially kept with its axis parallel to the polarizer axis. So assume this is your axis. So now consider this one as the axis of polarizer. So this green line represents your polarizer axis and the red line represents your analyzer axis. So initially they are kept parallel to each other. Okay, if they are kept parallel to each other, that means the angle between them is 0 degree. Now the question starts. The analyzer is then first rotated by an angle of 45 degree, then 90 degree, and then 180 degree. So how would the intensity of the light coming out of the analyzer be affected for these angles as compared to the initial intensities? Fine. So let I naught be the intensity when the axis of the analyzer is parallel to the axis of the polarizer. This green axis is the axis of the polarizer, this red one is the axis of the analyzer. Now consider your unpolarized light. Okay, this is unpolarized light. The vibration is along y and the vibration is along x. The wave is moving along z. Now your light is polarized by your polarizer and it is polarized along one direction, along y-axis. Now since your analyzer and your polarizer, they are kept parallel, that means there is no angle between them. So you have all of the light which was coming in will be coming out of this analyzer. Fine. So the intensity of this light, okay, assume it to be I naught. Now from the law of Malus we know the intensity of the light coming out, this I coming out equals to I naught. I naught means the intensity of this light, which is also same as this. Fine, nearly same. Okay, not exactly, but we can say, let us assume this is the intensity I naught. Fine, and cos square theta. Theta is the angle between polarizer and analyzer. So now consider the analyzer is rotated by an angle 45 degree. So now consider your plane of analyzer is rotated by an angle of 45 degree. In that case, what happens to the intensity of the light coming out? Substitute theta equals to 45 in this relation. So I can write intensity I equals to I naught times cos of 45 whole thing square. And what is cos of 45? Cos of 45 is 1 upon root 2. So 1 upon root 2 whole thing square will be 1 by 2. So intensity I will be I naught by 2. So the intensity of the light coming out will be I naught upon 2. So the intensity is reduced by half. So initial intensity is I naught and the output will be half of I naught. Fine. This is when angle is 45 degree. Fine. Similarly, you can try for your 90 degree and 180 degree. Fine. You can take this two as your homework. Fine. So you can take this one. Theta is 90 and theta is 180. Okay. Just substitute the angle here. Find out the intensity. Okay. I'll just write down the answer. You match your values. So in this case, if theta is 90, cos will be 0. So in this case, intensity should be 0. Check yourself. In this case, theta is 180. This one will be 1. The intensity will be I naught. Fine. So these are your answers. Okay. You solve this numerical and verify your answer from here. Fine. Next, we'll discuss plane of polarization and plane of vibration. So let's draw the plane of vibration first. Consider this axis as x-axis. Consider this axis as y-axis and this axis is your z-axis. Fine. Now let us assume our light is polarized along y-axis. So consider a light which is polarized along z-axis. Sorry, it is polarized along y. See, the vibration is along the y-axis and it is propagating along z-axis. Okay, this x-axis is not coming into the picture. A plane polarized along y-axis, vibrating along traveling along z-axis. So in which axis is the direction, or in which axis is the vibration? I mean, The wave is vibrating along the y-axis. Therefore, the plane of vibration will be your this red one. This represents the plane of vibration. Okay. So this plane of vibration is along y-axis. Fine. Let's take one more example. Now this time consider your light is polarized along x-axis. Therefore, in this case, the plane of vibration will be along the x-axis. Fine. So in which direction is the vibration of the waves represents your plane of vibration. So consider the similar wave, this wave. Fine. Now we know the wave is vibrating along y-axis. So the y-axis is the plane of vibration. Fine. This is the plane of vibration. So the plane perpendicular to the plane of vibration, the plane which is perpendicular to this plane, this red plane, okay, that plane is known as your plane of polarization. It contains the direction in which the wave is propagating and the direction perpendicular to the vibration. Okay, listen carefully, I'm telling perpendicular, not along the vibration. If it's along the vibration, then plane of vibration. If it's perpendicular to the vibration, then it is plane of polarization. So can you see this blue plane? This plane is perpendicular to the plane of vibration, isn't it? And it contains the direction in which the wave propagates. So this is known as your plane of polarization. Fine. For this one. Similarly, let's do this for this one also. For this wave also. Now look, if this wave is vibrating along which direction now? The wave is vibrating along x-axis. Vibrating along x-axis and propagating along z-axis. Then the plane perpendicular to the vibration. And it contains the propagation along the z-axis, then this is known as plane of polarization. Fine. So this represents the plane of vibration and this blue plane represents the plane of polarization. Fine. Okay. Fine. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So again, thank you.